Momentum is a concept you may have come across before. It is integral to the Newtonian view of the world. Objects that have mass are also capable of having momentum. Momentum is defined as the mass of an object multiplied by its velocity. As velocity is a vector quantity, then momentum is also a vector and can be subject to vector mathematics. Momentum varies as both mass and velocity vary. If velocity is kept constant, momentum is directly proportional to mass. As mass increases, momentum increases. If the velocity is negative, then the momentum still increases with increasing mass, but the direction of the momentum is in a negative direction. As the mass increases, the momentum becomes more negative. It does not return to zero. Return to zero is how reduction is described. If you keep mass the same, then you can still change momentum. Here, though, we don't have the problem of the sign with mass. Mass is a scalar quantity. It is either there or it isn't there. If it is there, then there can be more or less of it, but not negative amounts. As velocity increases, momentum increases. As velocity decreases, momentum decreases. Whatever causes velocity to change will also cause momentum to change. From previous work, we know that velocity is the rate of change of displacement with time. Displacement is distance with direction. These are vector quantities, and so are made of both a magnitude and a direction. If the direction of motion and the time over which the objects move are kept the same, then an increase in distance will lead to an increase in velocity, and so an increase in momentum. The reverse is true for a decrease in distance. If the distance over which the object moves is kept the same, and the direction stays the same, then a decrease in time will cause an increase in velocity. Time and velocity are inversely proportional. This increase in velocity will lead to an increase in momentum. If an object takes less time to travel a set distance, then it is moving quicker, and so has a greater momentum with mass, direction, and distance kept the same. If you take longer to complete the motion, you increase the time, the velocity is decreased, and so is the momentum. The final aspect of momentum is the direction in which an object is moving. Momentum is a vector, as velocity is a vector and displacement is a vector. This means that a change in direction affects the value of the vector. For our purposes, we will define forwards as the direction the momentum is applied in. This is angle 0. Any deviation from this direction will lead to an increase in the angle theta. Our value of direction is given as cos theta. When theta equals 0, cos theta equals 1. So when our object is facing forwards, we have the maximum value of displacement, velocity, and also momentum. So when we keep the distance the same, the time over which the object moves is fixed. A change in direction will lead to a reduction in displacement, and so velocity, and so momentum. As the direction is changed further, we have a further decrease in displacement, velocity, and then momentum, until the direction is perpendicular to our chosen direction, forwards. Our object is now moving perpendicularly to our chosen direction, so it is not contributing anything to the displacement of the object, or the velocity, or the momentum in our chosen direction, forwards. The displacement is 0, so is the velocity, and so is the momentum. The object itself may be moving, but is not moving in a desired direction at all, and so gives no contribution to any aspect we are observing. Once the object moves beyond the perpendicular, the displacement will increase again, but in the opposite direction to the one we have chosen. This means that the displacement, velocity, and momentum are all now increasing, but in an opposite direction, the negative direction. This continues until the vectors reach a maximum when the direction is 180 degrees from its start point. After this point, the vector will decrease in negative values until they are perpendicular again. Here, the vector value will be 0 again. Moving beyond this point, the values begin to increase again. Now they increase in a positive direction, the direction we have chosen to observe. Once the direction is facing forwards again, the vectors will achieve their maximum positive values. For most aspects of momentum at A-level, you'll be limited to one-dimensional applications, so don't worry about directions. They're included here, just for completeness.